Hello everyone, and welcome to the final lecture of this section. In this one, we're going to go over a couple of new data frame methods and operations that we haven't covered yet, as well as quickly recap on some of the most helpful and important of these two. Let's move on over into Jupyter Notebook and get started. Okay, so I've gone ahead and imported NumPy and pandas, as well as created this dataset here. There's quite a lot going on in this dataset, so before we move on, let's quickly go through and have a look at what our dataset is. Firstly, I've set the NumPy random seed to be 0, and this means that the random numbers produced will always be the same. So that way, you can follow along with me and get these same numbers yourself. Then, I've created a few different lists for different cities, customer types, employment status, and different product categories. Next, we use NumPy to create a random dictionary of 1,000 different customers using this data with the NumPy random functions. Finally, we cast this to a data frame and then create a new column for the total bill of the order, which is equal to the unit price multiplied by the quantity bought, as we can see here. And then this is what our final data frame looks like. The code for this can be found in the 06 additional data frames notebook file if you want to copy this over. And now that we've looked at our dataset, let's introduce the first topic for this lecture, which will be pivoting and the pivot table. And these are similar to the pivot tables that we looked at in Microsoft Excel, so the process will hopefully be quite familiar. And notice here that in our data frame, we've got certain columns like the city, customer type, employed, and product category that all contain categorical data. Within these columns, there are multiple rows that have the same value. So for instance, in our city column, we have multiple orders coming from the same place. So here we can see we've got a few orders from Houston and Phoenix, and then so on for the rest of the dataset. We can then use the pivot table method to pivot our data on these columns. We'll go ahead and say df.pivottable, and then there are 3 main arguments that we'll need to pass in here, and these are the values, the index, and the columns. For this example, let's go ahead and say that our value will be the quantity bought column. So this will be the column that we aggregate with our pivot table. So values are equal to, and then I'll pass in our column like so. Then we can pass in the index, which is the column that we want to group by for our pivot table index. So I'll just go ahead and say that we'll group by the product category column for our pivot table rows. And then for our column argument, here we can specify what column we want to group by, but for our pivot table columns, I'll go ahead and set this to be the employed column. So as this here is for our columns, when we run our code, we'll end up with 2 columns for each of our employment statuses, which were either no or yes. And then we'll get rows for each of our different product categories, as this is what we set as our index. I'll also add in a final argument here, which will be the aggfunc argument. And this is how we can set what aggregate function we want to use. By default, pandas uses the mean aggregate function, but I want to sum our data, so I'll set this to be equal to sum. Let's go ahead and run this, and then we'll get our output below. So let's quickly explain what we have here. We have our different indexes or rows for our product categories, and then the column we specified was the employed column. So we've got 2 separate columns for the employment status, so either no or yes. And finally, the values that we have for our actual data is the sum of the quantity bought. So these are the numbers we've got here. As another quick example, let's go through and create another pivot table. And this time we'll have a look at how our customer spending varied by the city and customer type. we'll go ahead and say df and then call our pivot table method. But then this time, for our index, we'll set it to be equal to our cities column. So this will create a new row for each different city. And then for our values, we wanted to look at the customer spending. So we'll say that our value is the total bill column. And then for our columns, we'll have this as the customer type. And then finally, we'll set our aggfunc or aggregate function to be the sum again. So here we can now see our customer spending grouped by the city in our rows and then their membership type by the columns. Okay, so that's how we can use the pivot table method to pivot our data in Pandas. Let's now move on and have a look at how to apply functions to each element inside of our data frames. Let's say that for some reason we need to count the number of characters for each row within our city column. If we tried to call the length function on our data frame for our city column, this would just return the actual length of the data frame, or the number of rows inside it, like we can see here. To apply this function to each individual row or element within our data frame, so to count the number of characters in each row, we can use the apply method. We'll just pass in the name of our data frame, so df, and then our city column, and then here we can call the apply method. Inside of our parentheses, we can pass in the len function, and then when we run this, it'll return a series containing the length for each row inside of our data frame. And the apply method will work for any function inside of Python or Pandas, including your own custom functions too. Let's now have a look at a quick and easy way to check our data frames for any NA values inside of them. And an NA value typically just refers to data that is either missing or not available. If we go ahead and say df and then call the isNA method, this will return a Boolean data frame with a true and false value for if that cell in the original data frame contains an NA value or not. If it does, it'll return true, and if it doesn't, it'll return false. For larger data frames though, this may not be too helpful, as it'll only show the first and last 5 rows of our data frame. But if we combine this with the .any method, we'll instead get a series that will tell us if there are any NA values in that column. The .any method will return false unless there is at least one element in a series or data frame axis that is true. So if there's even a single NA value in that column, then you'll be able to see it here. And doing it this way, you can quickly and easily identify any columns that contain NA values, making it easier for us to clean our data. To finish off, we'll just quickly go over 2 other methods that we've already looked at, and these are the dtypes and describe methods. These are very helpful for initially exploring your data, which is why I'm mentioning them again. The dtypes method will return the data type of each column in your data frame, and then describe will return descriptive statistics for an entire data frame, like we can see here. So these are both very good ways of getting a good high-level understanding of your data, and are typically among some of the first steps you'll take when exploring a new dataset. Okay, and that finishes off our section on Pandas. We'll be using Pandas plenty more throughout the rest of the course, so if you don't feel like you've got everything that we've covered here so far, then that's okay. We've got plenty more time to practice these skills. This section has covered the most essential skills and core knowledge that you'll need to work with data in Pandas. But it is a huge library, so there's nearly always more to learn. And of course, you'll probably pick up your own way of doing things as well. In the next section, we'll have a look at and go through some practice activities to help you consolidate your learning from this section. Thanks everyone, and I'll see you there.